Hi everyone, welcome back to my channel. This is Akshay Ruben. So in my today's video, we'll be discussing about how to solve problems using the Nodal method. If you don't know how to solve problems using the mesh method, you can watch my mesh method playlist, which is in the poll button. Here is the question. Find V1 and V2 in this circuit. So you can see the circuit. There's a 10 ampere current source, 10 ohm resistance, 5 ohm resistance, 20 ohm resistance, and 2 ampere current source. Now we need to find V1 and V2. So let's get into the problem. Step 1 is identifying and numbering the nodes. So first you need to identify the nodes and then you can number it. So we know that nodes are the junctions. So here we have one node here, second node here, and then this and that's the same. So and then one over here, like all of them joining. So let's name them. This node is node 1. This is node 2, and this you can take it to be earth, so V equal to 0. Now step 2 is marking the current that's entering and leaving the node. So you need to mark all the currents. So let me begin here. There is a 10 ampere current which is entering, so I can give 10 ampere entry, and then this 10 ampere splits here, and we say that it's flowing here as I1, here as I2. Now I2 enters here and it splits as I3 and I4. Since there's 2 ampere here, you can say that this is 2 ampere, so this will be I3. So that's it. First step was identifying the nodes and numbering them. Second is you need to mark the current. Third step is to mark the voltage. So the voltage here will be V1 and here will be V2, and the voltage here is 0. Now we need to solve this problem. If it is Nodal method, it's actually solved using the Kirchhoff's current law. We solve the mesh method using Kirchhoff's voltage law and the Nodal method using Kirchhoff's current law. So according to Kirchhoff's current law, the sum of current entering a node equals the sum of current leaving the node in a closed circuit. So the sum of current entering the node equals the sum of current leaving the node in a closed circuit. This is a closed circuit. So Kirchhoff's current law is applicable in this circuit. So I've written node 1 and node 2. So we're gonna do the Kirchhoff's current law in node 1 and node 2 to get two equations. In node 1, there's only one current entering, that's a 10 ampere, and there's two current leaving, I2 and I1. So we can write it here, the current entering equal to current leaving, so it will be 10 equal to I1 plus I2. We got our first equation. Now in the second node. In the second node, we can see that's I2 entering and then 2 ampere leaving, I3 leaving. So that will be I2 entering 2 plus I3. That's our second equation. In the next step, we need to find I2 in terms of V1 and V2, like I1, I2 and I3 in terms of V1, V2, V1 and V2, because we have to find V1 and V2. So first let's find for I1 equal to, so we know that I1 equal to V by R. So if you see, I1 is in this branch, here it is V1 and here it's 0. So the voltage here will be V1 minus 0. So let's write it down, V1 minus 0. And the resistance there is 10 ohm. So we write 10 ohm. Yeah. So that will be equal to V1 by 10. So we got our I1 in terms of V1. Then we have to find I2. So I2 is this one. It's moving from V1 to V2. So the current direction will be V1 minus V2 by the resistance here. So current will be V1 minus V2 by the resistance there is 5 ohm. So 5 ohm. We can't simplify that further. So next we need to find I3. I3, where are you? I3? Yeah, I3 is here. So I3, if you see here, it's moving from V2 to here. So that'll be 0. So it'll be V2 minus 0, and the resistance there is 20. So V2 minus 0 by resistance is, so that will be equal to V2 by 20. So this is our I1, I2, and I3. Last step is substituting the value of I1, I2, and I3 into the node 1 and node 2 equation and solve the simultaneous equation to get the answer. So let's get started. The first equation was, I'll write it over here. So, I'll just write it over here. 10 equal to I1. It was I1 plus I2, so I1 was V1 by 10. So 10 equal to V1 by 10 plus I2 we got is V1 minus V2 by 5. So V1 minus V2 by 5. This is our equation number 1 in terms of V1 and V2. Now our equation number 2 was I2 equal to 2 plus I3. So I2 we already know, it's V1 minus V2 by 5 equal to 2 plus I3 is V2 by 20. So you can write here V2 by 20. Our second equation. Now we need to solve these two simultaneous equations. We can solve by grouping them to one side. So it will be V1 by 1 by 10 plus 1 by 5 minus V2 by 5 equal to 10. You can type it directly to the calculator, this one. Then for the second equation it was this, so we need to group these to one side. That will be minus V1 by 5 plus V2 1 by 20 and plus 1 by 5. That's equal to 2. I mean -2 because this 2. So this is -2. So this is equation number 2. Now we can directly write it down in the calculator. Type it down in the calculator and you will get the answer of V1 and V2. So I've typed the equation into the calculator in decimals, and so I got the value V1 equal to 60. I write it down. V1 is 60 volt and V2 is 40. So I write it down. 40 volt. So that's how you do Nodal method. It's easy too. So let me brief it out. First step we did was identifying and numbering the nodes. So that's the red here, 1, 2. Then we did is marking the current. So 10 ampere, I2, I1, I3, 2 ampere. So we marked the current. Then we marked the voltage, and then using Kirchhoff's current law, we wrote equation number 1 and equation number 2 for node 1 and node 2. And then we wrote I in terms of V using V by R formula. And then we substituted this I1, I2 and I3 into this equation. And we got this. We simplify the equation so that we can type it in the calculator. We typed it in the calculator. We got the answer V1 equal to 60 and V2 equal to 40. Next is, as you know, is doing it in the matrix directly instead of writing all these steps. You can do it directly in the matrix and you get the same answer. So to do in the matrix, first will be like, let's just say we have x minus y and z, and you have your V1, hope you can see, V2 equal to I1, I2. Oh, if you see this, the x value here, the x here, is the sum of reciprocal of all resistance connected to node 1. I'll repeat, sum of reciprocal of all resistance connected to node 1. That's x. So when you do it, x node 1, sum of reciprocal of all resistance. So in node 1 there are only 2 resistance, that's 10 and 5. So reciprocal of them will be 1 by 10 plus 1 by 5 sum. Then y is the resistance that's common to node 1 and node 2. Node 1 and 2, the resistance common is 5, and the reciprocal, it will be the reciprocal 1 by 5, and it will be always negative. So directly write 1 by 5. Then that you already know it. It will be the sum of reciprocal of all resistance connected to node 2. So here you have 20 and 5, so sum of them will be 1 by 20 plus 1 by 5. Now you can write V1, V2 equal to, so I1 is 10 and then I2 is minus 2. 10 is the current entering and 2 is the current leaving. So leaving will be minus 2 and entering will be 10. So if 10 was leaving, it will be minus 10, but then 10 is entering and 2 is leaving. So now you just type it into the calculator. This will be like this. Yeah. Now you type it in the calculator and you will get the answer for the matrix method. You can directly do it instead of doing all these steps. You can just skip all the hard work. So I repeat how to do this. X is sum of reciprocal of all resistance connected to node 1. Y is reciprocal of the resistance that's common to node 1 and 2, and it will always be negative. And Y is the same. Z is the sum of reciprocal of all resistance connected to node 2. So, and then 10, if current is entering, it's positive, and leaving, it's negative. You can directly type it into the calculator and you will get the same answer. That is V1 equal to 60 and V2 equal to 40. Thank you for watching this video about nodal method. So there will be other parts of nodal method coming up in my next videos. So keep in touch, subscribe to my channel so that you get notifications when I post a video. Like this video if you understood, and if you have any kind of doubts you can comment. And yeah, that's it. Thank you. Bye bye. See you guys on another video.